One of the first talks I saw Tamsin do actually is, which she hasn't mentioned on her bio, which I am going to read. I was going to skip over, but it's so impressive. But yeah, what I saw, which she's missed out, is that she was actually a particle physicist. In fact, I think your doctorate is potentially in particle physics. And I remember your first two massive graphs, which said I went from this, which was literally a curve like this, to dealing with massive uncertainty with like squiggles and squiggles and squiggles. So Dr. Tamsin Edwards is a climate scientist, and she specializes in quantifying the uncertainties of climate change, and in particular in climate model predictions. And her work is in Antarctica and the Greenland ice sheet. I am absolutely delighted that you've come to talk to us. I've been trying to get to you for years and years, and I know you've been at Blue Dot Festival, if Jodrell are here, but it's great to have you here. Let me tell you a little bit about Tamsin. She was actually the lead author in the IPCC 6 assessment report that was published in 2021, and a contributing author to the IPCC special report on oceans and cryosphere in a changing climate in 2019. Tamsin regularly provides expert advice on climate science to the public, to policymakers, to media and business. She is an award-winning science communicator, including through Twitter and her blog on the Public Library of Science, which is known as All Models Are Wrong, and articles for The Guardian. She also leads the King's Climate Hub of Climate Change Researchers and co-presents the BBC Radio 4 series 39 Ways to Save the Planet. So absolutely delighted that you're here. Thank you so much, Tamsin. The floor is yours.
Thank you for that lovely introduction, and I'm sorry for going AWOL. I didn't realise you were going to finish a little early, but that's great. And thank you so much for inviting me again. And I'm so happy to be here. And I know it's the end of a longish day of talks and potentially travel, and I'm standing in the way of other things. But hopefully, I can give you something which is designed to be a bit of a primer, I guess, around COP and climate change. I wrote this talk for today to try and think about some of the things that I think are kind of key points around this, and key kind of points of confusion or concern as well. So you all know climate change is real and you're all worried about it. I don't need to tell you that, but I thought it would be worth saying a couple of things around the IPCC reports that came out last year and this year. So on the left here, we've got the physical science basis, which is the working group 1, which I was, I should say, a lead author of, not the lead author of. But it just means basically an author of, and the impacts report that came out this year, the impacts of climate change. We are already at 1.1 degrees of warming, and this means that some types of extreme weather have already become more frequent and more severe. I think we know this kind of intuitively, but something like an extreme heat event that previously was expected once per decade before our influence is already 3 times more likely, and heavy rain 30% more likely. 1.5 degrees of warming takes that extreme heat event up to 4 times more likely, 2 degrees of warming to nearly 6 times more likely. And if we reached a 4-degree world, then that event would be expected nearly every year. Sea level rise, my area. At 2 degrees of warming, we predict around 0.5 metre of global average sea level, which doesn't sound like much, but just like 2 degrees of warming, it has a big effect on the extremes. So extreme sea levels, this is Dawlish, I'm from Devon, the Dawlish coast where the train line disappeared under a flood. Extreme sea levels previously seen once per century will be 160 times more likely. And under just a bit more sea level rise in a 4-degree world, that number could triple. And some aspects of climate change could be reversible if we were to bring temperatures back down to previous levels. So some things like the extreme weather would respond to that. But some aspects would be irreversible. The oceans will continue to warm, the ice sheets will be reduced, and sea levels will remain high for hundreds to thousands of years, so beyond any meaningful human timescale. For example, going out to the year 2300, if we have warming of 2 degrees over that period, then the sea level rise could get up to an average of 3 meters, enough to change coastlines around the world. And if we had unrestrained emissions, which thankfully we think is pretty unlikely now, through that whole period, then that could increase to 7 meters, or there are predictions that go to more like double that. And in terms of the impacts of climate change on us and other species, there are risks that are already high that are transitioning to very high at 1.5 and 2 degrees of warming. This is one of the IPCC's burning ember diagrams. And unique and threatened systems is shown on the left, where the sort of purpley colour comes about at 1.5 degrees. So, for example, at 1.5 degrees of warming, coral reefs are predicted to decline between 70 and 90%. Extreme weather events are the other concern, very high risk at 2 degrees of warming. And there, it's all kinds of extreme weather, but for example, wildfires, the burned area of land affected by wildfires is predicted at 2 degrees of warming to go up by over a third. And of course, climate change increases the risk of loss of biodiversity. These maps show loss of biodiversity, so local extinctions under 1.5 degrees of warming or 3 degrees of warming. You can see some of the hotspots around the world there. And the predictions are that up to 14% of the land species that have been assessed will likely face very high risk of extinction just at 1.5 degrees of warming. And if we reached a 4-degree world, that could go up to 40%. So that was the motivation if we needed it at all. What about the global framework to deal with it? This talks about COP. Well, COP stands for, for those of you who aren't familiar with it, Conference of the Parties, the annual meeting set up under the UNFCCC, the United Nations Framework Convention on Climate Change. And parties effectively means the different countries of the world, although the EU acts as one party. And back in 2015, we had the 21st of these held in Paris, where probably the most important climate treaty ever was signed, the Paris Agreement. And this is the really key bit of text in terms of the warming levels. It wasn't the only thing covered. This agreement aims to hold the increase in the global average temperature to well below 2 degrees above pre-industrial levels, and to pursue efforts to limit the temperature increase to 1.5 degrees above pre-industrial levels. So pursue efforts to limit. And 1.5 degrees, of course, comes up a lot in general and in this talk as well. And that Paris Agreement had a whole framework of things around it, the most important of which in terms of emissions and global warming is that each country submitted a pledge for cutting their greenhouse gas emissions this decade, which was two things. It was decided by them how much they cut, and it was voluntary, it was non-binding. And these pledges are called the nationally determined contributions. I'll keep calling them in this talk NDCs. And that might seem crazy, right? Decided by them and voluntary. It seems pretty weak, but it's widely agreed that this flexibility is the main reason that the treaty was signed at all. And you'll see that actually it's not quite as bad as that perhaps initially sounds. And one reason for that is that the starting pledges are just the beginning. So Glasgow, the Glasgow COP26, of course, just across the river, last year was a special COP in the Paris Agreement because it happened 5 years plus one for the pandemic after Paris. And it was special because in the Paris Agreement, countries must increase their NDCs, the ambition, the level of emissions they say they're going to cut every 5 years. And this is called the ratchet mechanism. Ratchet, I discovered when I was Googling images to illustrate this, is a transformer as well. So Glasgow was a special COP. The UK was hosting a special COP for this reason. But was that COP a success or a failure? We get asked this question all the time. I wrote a blog post, All Models Are Wrong, this blog post here just before COP, talking about what things we might look out for, how we might judge success or failure. It's a kind of primer around COP, and if you don't know your NDCs from UN, FCCCs, this kind of thing. And it went through these different things that we might look out for. So some of the key things that happened at COP were that those NDCs were updated. We had over 150 updated as was required. And then there were also, you probably heard in the news, quite a lot of separate pledges around individual sectors. So, for example, we have here methane. There was a pledge signed up to by lots of countries to reduce methane emissions by 30% by 2030. And lots of countries signed up to one on forests, which was to halt and reverse forestry loss and land degradation by 2030. And these two things together, the updates of the NDC pledges and the sector pledges, reduced what we'd call the ambition gap, the gap between where we need to be and where we actually are in terms of future emissions, by about a quarter. And you can see the relative impact of each of these by the size of the bars. So the NDCs were more important, and then the methane and the forestry were the most important of those sector pledges. So there was progress at COP26, but it wasn't enough. And this is a kind of a theme of the talk, really, of the mixed picture throughout all of this story. So I would say that, as I put in the blog post, I would still say that 1.5 is alive still, as the government wanted to put it last year, but it's very much on life support. Those pledges, the current round of the NDCs just go to 2030. Future NDCs will go further, but the current round just go to 2030. So what about thinking beyond 2030? And we are doing quite a lot of that. Because what we are acknowledging, finally, is that in the long term, we have to get to net zero emissions, and that's the only thing that's going to stabilise climate change, that's going to stop warming at the point that you reach net zero. And net zero is a critically important concept. Lots of you, I'm sure, will be familiar with it. It doesn't mean zero emissions because we don't think we can get down to zero emissions. It means net zero because we are removing carbon dioxide from the air as fast as we emit it. So it's in balance. And that brings me to a really key concept, which I really often see confused in the public and used interchangeably. I teach it to my students at King's as well. And in fact, it's a bit confused, I would say, in the Science Museum exhibit on this. And I told them that when I saw it a couple of weeks ago. The difference between carbon capture and removal. It's really important to think of, if you like, the atmosphere is a big box, and this is about the flow of carbon dioxide kind of into the box or out, a bit like those scales I showed on the previous slide. So carbon capture is what you might call kind of prevention. It's stopping CO2 going into the air that wasn't there before. And what happens is that you take a source, it only happens at a source of CO2, like a coal power plant, and you have some kind of outgoing pipeline of CO2, and you have some kind of infrastructure that will scrub that CO2 out of the pipeline, just like we do for sulfur dioxide and some other pollutants as well in industry. And so you extract that CO2 from the outgoing pipeline, and then you store it hopefully securely. So that's a prevention. The other critically important concept that's becoming more and more talked about all the time, it's very important that we do, is carbon dioxide removal. And this is kind of like a cure in the sense that you're undoing what was done before, and you're taking CO2 out of the air that had been put in the past. That can be done anywhere on the planet. CO2 is kind of mixed around the whole planet. And there are kind of, broadly speaking, two ways of doing this. The most famous bit of technology for doing this is a tree. So we have these nature-based solutions like planting trees, asking farmers to use methods that keep as much carbon in the soil as possible. And then we have tech solutions, so bioenergy with carbon capture, where you're using crops to take that CO2 out of the air, to remove it, and you capture the CO2 in the processing and store that. All the sort of purely technological methods, this one on the right here, direct air capture, that's a picture I took at the Science Museum of the example machine they've got there, and I definitely recommend having a look at that exhibition. And that's a kind of purely tech method. But I very much put cure in inverted commas here, in quotation marks, because all the methods we know of to remove carbon dioxide from the air, which obviously sounds like a wonderful thing, well, let's just suck it back out again and everything's solved, Bob's your uncle, 1.5 degrees. All of these are affected in a major way by one of the kinds of concerns I've listed. So land use for planting forests, for example, the effectiveness of storing carbon in trees when they're vulnerable to disease or fire, the scaling up in time to have a big effect sort of globally, the cost, direct air capture is a neat technology, but it's expensive, it takes a lot of energy. So cure very much in terms of how they work, but not necessarily in terms of the realism of putting them into practice right now. So that's the idea of net zero, and the fact we have to get there at some point to stop climate change. Well, where did this idea of 2050 come from? Net zero by mid-century, and we hear lots of these pledges. Back in 2018, the IPCC had this special report looking at what we would have to do to limit warming to 1.5 degrees, sort of commissioned after the Paris Agreement, if you like. And what this graph shows on the left in the red curve are the past CO2 emissions up to 2018 or so, from all different sources. And then on the right, those are the pathways that are going to be consistent with either 1.5 degrees of warming or a little bit of overshoot and coming back. And you can see not only do they plummet very quickly, but also they get to zero, and well, in practical terms, net zero, around 2050. And these are pathways for a 1.5 degree warming limit. That sort of deadline goes back to 2075 if it was a 2 degree limit. What happens after 2050 is something, again, we don't really talk about probably enough. It goes negative. After net zero comes net negative, and we have to be removing CO2 from the air faster than we emit it. So you can see that's a pretty daunting challenge for the end of the century. And of course, we're not in 2018 now, we're here, so we're even closer to that precipice of emissions for the 1.5 degree limit. So, how are we doing so far? Most of the rest of the talk here comes from two sources. One is the third of those IPCC reports. So the Working Group 3 report is on mitigation. In other words, reducing emissions, extracting emissions with carbon dioxide removal, extracting CO2 from the atmosphere. And also from the really excellent website, I highly recommend it, climateactiontracker.org. So the question I get asked all the time, are we too late? If there's one thing I want you to take from this talk, it's that this is not a binary. Climate change is not a pass-fail issue. There's a spectrum. There's a spectrum of outcomes that we're going to face in the future. And it's a spectrum of kind of assessment of how we're doing along the way. There are good and bad parts to it. There's partial success and partial failure. And I very often see with people who are concerned about climate change this idea of, are we too late? Are we screwed? Are we, more rude words than screwed? And this idea that there's a kind of a threshold at 1.5, and if we reach 1.6 degrees, then we get runaway warming until we're at Venus. And it's not the case, it's a spectrum. And of course, we want to keep as close to this end of the spectrum of temperatures, where we are now, as we can, but it's not a binary. So I will talk about reasons for optimism, reasons for concern, and then I thought I should probably sandwich that with some reasons for optimism to finish on again. So first, reasons for optimism. This is a graph of greenhouse gas emissions from 1990 to today by different types. You can see CO2 from fossil fuels and industry in blue is the biggest chunk there. And what this is showing is that the increase in emissions has slowed down. Now, it is still an increase, but it slowed down. So the last decade increased less than the previous decade as a percentage. So it slowed down, and that global average hides actually some very substantial cuts for individual countries, whether it's due to climate policies or other factors. There are some individual countries that are cutting their emissions year on year very fast, consistent with the kind of rates we need to be doing in the near future. So there are countries with these fast cuts masked in that slowing there. And I mentioned that the Paris Agreement requires the NDCs, those pledges, to be updated every 5 years. And I talked about how most countries did that last year, either just before or during COP26. But of course, they can be updated any time. The Glasgow Pact actually said we sort of urge countries to revise them again this year because the ambition wasn't enough. And some countries have done that. So Australia, with a new government, have submitted a new NDC, and that has now been assessed as almost sufficient, so kind of heading for about a 2-degree world. So not a 1.5 degree, but much better than it was before. And not only NDCs are getting updated all the time, can be updated any time and have been updated, but the policies that actually put those pledges into practice, that make those pledges happen, also change, of course, over time. And we saw this year the US put forward the Inflation Reduction Act, and that's widely seen as the most radical and effective climate policy probably ever for the US. And so their policies have been assessed as just on the borderline of this 2-degree kind of consistent target. So that's if every country in the world had the same policies and targets, then it would be we'd be heading for a 2-degree world. And the EU as well. So just this month, 15th of September is the news article date, increased the ambition in response partly to climate policy, but also to Ukraine, to increase the target for renewable energy this decade from 40% to 45%. And so the target for the EU was already actually close to compatible with 1.5 degrees of warming. And I think this confirmation of this policy will probably mean that the policies are also assessed as 1.5 degree compatible once Climate Action Tracker has updated that country level assessment. And so those are the short term, the NDCs for this decade and the policies being put into place now for this decade. But in the longer term, there are also these net zero pledges being made more and more around the world. These have been coming in all through the years. So basically, we've now reached more than 140 countries with net zero targets, and those cover 90% of global emissions. We have small-scale net zero targets. We have hundreds of cities and regions. We have many, many businesses also putting these net zero pledges on the table, typically for around 2050, sometimes a little later, occasionally a little earlier. And if anything, this slide shows you that the argument about climate change has been won, right? It is widely agreed that we have to get to net zero to stop climate change, and that is a thing that we should be doing. Most countries have now agreed that. And sometimes I see people thinking that nobody even thinks we should be doing anything still. And you can see that it's not the case. What we have to separate is the ambition, which is there, from the delivery, from the actually putting it into practice, which is, of course, more difficult. And so all of these improvements year on year to the NDCs, to the policies, and to the net zero pledges mean that our temperature projections are improving over time. This is the key part of the Climate Action Tracker, showing the projections under the kind of current policies, pledges, net zero targets. And I see these numbers go down over the years. I've used the Climate Action Tracker for some years, and I see these numbers go down every year. So we were originally potentially heading for something like a doubling of emissions this century, which would take us to that 4-degree world that I talked about. So that's right up at the top of the scale. But what you can see is that the climate policies, laws and regulation that are already in place take us well below that to hopefully a good chunk below 3 degrees of warming. Okay, still not good enough, but better than where we were heading. The NDCs, which are, pledges, and they don't necessarily have the detailed policies outlined to get there, take us down further if they're successful to 2.5 degrees of warming. If you then also add in the net zero targets that are binding, so the UK is one example of a country that's put net zero into law. We have to legally reach net zero. So if you include all the countries that have done that, we get down to a little over 2 degrees as a central estimate for the future warming. And you may know where this is heading. If you add all the targets, so not just the binding, but the non-binding, anyone that sort of said, we intend to do this, pledges and targets, we actually go a little below 2 degrees of warming. And in fact, the bottom of that uncertainty range is at 1.5. So there are uncertainties here, and it's very much the implementation is the key, but it is historic, as this article says, that our ambition, our pledges, our promises about the future have now gone below 2 degrees for the first time in history. Climate studies as well, it's important to remember that they often show projections under the very highest emission scenarios, which we probably think aren't possible, let alone likely anymore. This is a graph from the IPCC first report of different scenarios that they use to make climate predictions. This is the carbon dioxide under 5 different scenarios of the future. And this red one at the top, called SSP 585, has a tripling of emissions this century, not even a doubling. And so that is predicted to head to 4 or 5 degrees of warming. And we still often see climate studies looking at what the impacts of that warming would be and getting those terrible headlines. What we're actually predicted to head for just under the current policies is 2.5 to 3 degrees of warming, which is a bit more like this intermediate yellow scenario here. So just bear that in mind. If you see SSP 585 or the older version of that, RCP 8.5, those are these very, very high emissions. And so we don't think we're heading for that world. So the reasons for concern. There is still an ambition gap. The NDCs are still too weak, far too weak. So the current projections are that emissions will flatline this decade instead of increasing. And what we need them to do is nearly halve if we want to keep to the 1.5 degree warming limit, or reduce by just over a quarter for 2 degrees of warming. So they are too weak. That's the ambition gap. There's also the delivery gap that I mentioned. So the policies, as you saw, are weaker. So we're heading for a bit more warming than that. Those policies have to be realistic, enforced, monitored. We can't be, for example, planning lots of new fossil fuel infrastructure while we, on the other hand, say that we're going to cut our emissions. The UK is kind of exemplifies in a way this mix of, good news and bad, I suppose, or good news and concern. Not everyone knows that the UK is world leading in its ambition on climate change, in its emissions targets. The NDC is one of the few countries that's rated as 1.5 degree compatible. We are very evidence-based, we are very science-based in our climate, in the Climate Change Act and in this target here. And then the policies to put that into practice have been assessed by the independent body for scrutinising these, the Climate Change Committee. And they've said, well, there are good, credible plans that we think are going to be successful for electricity and transport. Great. But there are still concerns, significant risks of not delivering on buildings, things like energy efficiency and agriculture. There's not really much policy on diet. We've got to replace EU agricultural policy post-Brexit still fully. So we're not quite as good on the policies, still actually heading for 2 degrees, but not as good as the target. This year, what kinds of things can we look out for? Well, the most close one is on Sunday, the Brazil election. If Lula gets in, he is someone who has pledged to protect the rainforest, to increase the ambition of the NDCs to be better focused on the Paris Agreement. Of course, we have COP27 in Egypt in November, which has been dubbed the implementation COP, or the kind of let's get on with it now COP. And lots of focus on things I haven't talked about here, like adapting to climate change, on finance for developing countries, biodiversity. There's links with the other COP, the biodiversity COP, which is COP15 happening in Montreal in December. So that's expected to hopefully produce a big result called the Global Biodiversity Framework, a big new plan. We hope there'll be more updated NDCs as the Glasgow Pact asked. Probably unlikely to see much there. Even Egypt itself, who's hosting, submitted an NDC this year that was judged insufficient, highly insufficient. But we might see updated plans, for example, for the UK, who saw a legal challenge for their net zero strategy saying it wasn't detailed enough, those policies weren't specific enough and were too high risk to achieve net zero. And so therefore it's going to have to revise the net zero strategy legally because of that challenge by Friends of the Earth and others. So coming back to optimism to finish, the IPCC third report, the mitigation report, made an assessment that we can reach that target physically of halving emissions this decade. And not just physically, but affordably. It said there are options, affordable options available now in all of these different sectors that can halve emissions by 2030 or even better. And I definitely recommend you go and have a look at some of the press slides for that report, because it shows, for example, how costs of renewables have really plummeted and dipped below fossil fuels, for example. It's always important to talk about the opportunities and what we call the co-benefits of climate actions, because that is what's motivating people as well. The improvements in air quality, the food security, biodiversity, inequality, supporting the sustainable development goals, which are shown here. These are things that are motivating people aside from climate change. And people are just getting on with it. So, by people, I mean individuals, I mean businesses, charities, schools, local councils, lawyers, engineers. People are just getting on with it because they think it's inevitable, because they think it's good for the planet, because they think of the co-benefits. So to permit me to plug the radio series again, our series has 39 short episodes on really interesting, novel, exciting, optimistic methods of reducing emissions or extracting CO2 from the air, because people are getting on with it. So I shall give Greta Thunberg the last word to reinforce the point that I was making about it not being a binary, not being too late or a pass or fail. It's never too late to do as much as we can. Thank you.